This is our last lesson in Unit 2. So after this, we've learned everything that's going to be on the DCA. So this is a system of linear inequalities word problem. We've done word problems with systems of equations, but this one has inequalities. You can work at most 20 hours next week. You need to earn at least $126 to cover your weekly expenses. Your dog walking job pays $9 per hour, and your job as a car wash attendant pays $6 per hour. The maximum number of hours available at the dog walking job is 12. Let X be the number of hours dog walking and Y be the number of hours working at the car wash. Write a system of linear inequalities. Okay, so again, the problem that some students have is putting too much information in one equation or one inequality. So let's only put the minimum information needed in each inequality. So let's take a look at this first sentence here. The first sentence says that you can work at most 20 hours next week. So that means you can work equal to 20 hours or you can work less than 20 hours, at most 20 hours next week. So you're going to work X hours dog walking and Y hours at the car wash. So this inequality has nothing to do with how much money you're making. So we're not going to include any wages in this first inequality. Okay, next, let's read that second sentence. The second sentence says you need to earn at least $126 weekly to cover your weekly expenses. So at least 126. So that means we can earn equal to 126 or greater than. Your dog walking job pays $9 per hour. So dog walking is the X. So you can make 9X dollars dog walking. And the car wash is $6 per hour. So 6Y. Let X be the number. Okay, I missed a sentence. The maximum hours available at the dog walking job is 12. So this last inequality only has to do with X, and the maximum is 12, so we can work equal to 12 or we can work less than 12. Now we're going to graph the system of inequalities. Before we graph it, let's go ahead and get these in standard form, and then we can see what scale we need to use when we number our graph. So that first one, X is less than or equal to 12, that's already in standard form. For the next one, let's move the X to the other side. And then lastly, for this one, let's move the 9X to the other side. And then let's divide everything by 6. So when I divide by 6, I'm going to get negative 9/6 for the slope. And that's going to reduce to negative 3/2. So 6Y is greater than or equal to negative 3/2 X plus. Now when you divide 6 into 126, some students don't know this little trick. So you just look at it and do your division like mentally. So 6 goes into 12 2 times. And then 6 goes into 6 1 time. So looking at our inequalities, our y-intercepts are going to be 20 and 21. So we don't need to have any weird scale. I think we can number by ones, and we can still fit our y-intercept to 21. So don't number every box. You have more important things to do with your life than to spend time numbering every single box. Okay, there's exactly 21 boxes. And so what does Y represent? Y represents the number of hours at the car wash. And I just kind of looked back in the problem to see what Y was before I labeled that. Excuse me. Okay, now let's number the x-axis. 1, 2, 3, 4. Okay, so in the x-axis is the number of hours dog walking. So our first inequality is x is less than or equal to 12. So if I were to graph the line x equals 12, that would be a vertical line. Your ID works great as a straight edge if you don't have a ruler. So use your ID. So I'm going to do a y-intercept of 20, and then a slope of -1 is just going to be 1 unit down and 1 unit to the right. So this is going to be where I'm going to draw my line. This is a solid line because you have that less than or equal to symbol. It should come down across the x-axis at 20 also, since my y-intercept was, or since my slope was -1. I'm actually going to put a little shading here so I remember which direction I'm going to be shading. Okay, and then this one is a less than or equal to also. So we're going to be shading beneath this line I just drew. Just put a little shading there. Okay, and then the next one has a y-intercept of 21 and the slope is -3 halves. So when I do a slope of -3 halves, I'm going to be going down 3 and then 2 to the right because it's rise over run. So when you do your slope, you should always be going to the right. And then just if there's a negative sign, put it with the numerator, and that means you're going down that many units. If it's positive when you do your slope, let's say we had a slope of positive 5/4, you'd be going up 5 and 4 to the right. But graphing that slope of -3 halves, we go down 3 and over 2, again down 3 and over 2. Okay, this one is also a solid line since we have that less than or equal to, so putting a solid line in here, something like that. Okay, and then this one is shaded greater than or equal to, so let's go back and put the shading back here. I deleted it. And this one is going to be shaded above that line since it's greater than or equal to, so let's get a third color. Okay, so I can kind of see where my shading is going to be. So it's going to be to the left of that vertical line. It's going to be beneath the that first slanted line I drew and above the other one. So actually, since it looks like the shading is going to be a little bit of a mess for me, I'm just going to shade where the 3 regions would overlap. So they're going to overlap right in here. So that's where I would see the shading of all 3 colors. It's to the left of that vertical line. It's going to be beneath that first slanted line I drew and above the last one. So that's my solution region. It says give a sample point in the solution region and give its meaning in the context of the problem. So because these are solid lines, I can pick any line, any point inside the solution region, or I can even pick any point that's on one of the lines. So I could pick this point right here. So that could be my sample point, and the coordinates of that point are 12, 5. And remember in the problem, X was the number of hours dog walking. So we could do 12 hours dog walking and 5 hours working at the car wash. Show that this point works in A by that I chose in A works by checking it in the original inequalities. So my first inequality was X is less than or equal to 12. And so 12 is less than or equal to 12. The second one was X plus Y is less than or equal to, I believe it was 20. So 12 plus 5 is less than or equal to 20. So yes, 17 is less than or equal to 20. And then the last one, 9x plus 6y is greater than or equal to 126. Nine times 12, I believe that's 108. So 138 is greater than or equal to 126. So it checks out in all three inequalities. So that means it's part of the solution region. So we could actually check a point to see that a point's in a solution without even looking at the graph, as long as the point works in all three inequalities.